Okay, so this video is about properties of logarithms. First of all, the first rule of logarithms is that log base b equals to, say, y of x. All right, so this is my base here is x. This is my exponent, and this is number. So basically, the first rule of logs, if I gave you log with this number as my base of some number b equals to y, the way we solve that is this. Well, before I tell you, think about it. If I asked you to solve this equation for the variable x, what would you do? All right, so probably have no idea. Well, this is how you actually solve it. In order to solve this, get this exponent from being here, you have to take this x, raise it to that power. So it becomes x raised to the y power is going to equal to b. And that's how you solve log equations. You take the base, you raise it to the power of whatever it is on the other side. In this case, just one number. It might be 7 numbers. This all would be an exponent. And then it's going to be equal to that number. All right, so that's the first property, most important property, I think. So let's start talking about it. All right, so 3 new examples. Solve the equation for x, given what we just learned about one of the properties of logs. So if I solve this equation, I know in order to solve it for x, I have to take this x, raise it to the power of 2, because x squared is going to equal to 7. So if x squared equals 7, well, you probably square root both sides in order to solve that for x, because this is what x squared is equal to. You want to know what x is equal to. So you square root both sides, you get x is equal to positive or negative square root of 7. Now, we don't take the log of negative numbers. Our base can't be negative numbers. So we don't need both positive and negative. Our only answer is positive square root 7. Try to make it a little better. Anyway, it's positive square root 7. In the second example, what we have is log base 3 of x equals to 9. Well, it's going to be 3 to the 9th. 3 to the 9th power equals x. This is going to be 3 cubed times 3 cubed times 3 cubed, which is 27 times 27 times 27, which is a huge number. So I'm just leaving it as 3 to the 9th power because it's going to be a number, it's just easy to call it 3 to the 9th power. Unless someone really wants to know what that is, I'll leave it there. All right, in the last example, let's solve this one for x. So I'll take this base, raise to the power of 1. It'll give you 4x to the first power equals to 3. To raise something to the first power didn't really change much. Each exponent is raised to the first power. So it's 4 times x equals to 3. So you divide by 4. And x equals to 0.75. And that's how we can use the first property of logarithms. All right, so if you think you got it, great. Get that as a note. Pause the video if you need to, but I'm about to erase this now. Next property is called the product property. And basically says this. If I give you log of a, b, c, y, basically all these things we multiply a, we multiply to b, we multiply to c, and also, I didn't put time signs there, but it's still be multiplied to y. If all these things have been multiplied, we can expand this and make it log of a plus log of b plus log of c plus log y. So addition between logs is the same thing you have in the product of the numbers that follow log. So that's what the product property allows us to do. And we can go to the converse of that. So if we actually went backwards, let's look at it that way. So we look at it backwards, we can say the reverse is also true. All of this has equal to the log. Since all these numbers have been added together, log of x plus log of 2 and so forth, I get a product of all these numbers. So basically it's going to be x times 2 times y times z. X times 2 times y times z. I really like having that 2 come second, so I'm going to rewrite that as log of 2x y z. I just group it in parentheses so there's no confusion that that's all together. But yeah, so we can condense it using the product property as well because you can't have one without the other. So if I can expand it this way, and also go backwards and condense it to be this. All right, let's talk about the next property. All right, so the next property is a quotient property. Basically, a quotient means fraction, and if you think if multiplication means addition, what do you think division means in logs? Well, you probably think it means subtraction, which is true. So basically, if I have this, I can expand it to be log of the top part, 2x, subtract log of the bottom part, 5. So the subtraction here tells me that it came from division previously. Also, since we learned this means multiplication, that means I can expand it further. I could really call that log of 2 plus log of x plus log of 5. And it doesn't matter whether you put parentheses around these numbers or not. Sometimes I do, sometimes I don't. If I feel like it might confuse you, I'll just put it there every time. But log of 5 or log parentheses 5 is the same thing. All right, so and that goes backwards as well. So if I thought about the converse of that one, it would be some long expanded problem, and I'll condense it down to a single logarithm. Let's do that now. All right, so if we look at this, all the ones that have subtraction between them are in the denominator because they've been divided, and all the ones with plus signs in between them are in the numerator because they've been multiplied together. So if that's the case, I know I have a single logarithm of log of, on the bottom, it should be 4 times 9 times z. We call that 36z. Because 4 times 9 is 36, so it's 36 times z. In the numerator, it should be yz. You may see that these z's cancel, so you can save yourself a step and cancel them. So our final answer would be log of y over 36. So now, this long expression is now condensed to one single logarithm. Hey, if you take a look at that, now I just kind of notice it. Log of z here, then negative, log of positive z there being positive. You may could have canceled them out from the very beginning, because those are added together to be 0. All right, let's talk about the next property. Exponent property with logs. Essentially, exponent property says if you have an exponent, it has the right to come down on the logarithm. So it'd be x log of b is equal to log b raised to the x power. So they're the same thing. That's the exponent property says. You can go backwards. If I gave you 3 log of 2, well, my exponent property says this 3 has the right to come up and become log 2 to the 3rd, or log 8. So I could take 3 log 2 and call it log 8. They're equivalent. So that's what exponent allows us to do. Either come down or go backwards and come back up and become an exponent. One of the two. All right, next property. X group aren't really properties, more of generally accepted facts. The log has a base of 10. So you might know it from previous videos, but just accept the fact that if I gave you the log of b, there's understood 10 here as the base. Also, generally accepted fact, natural log has a base of e. So if I gave you natural log of e, and the base is e, the natural log of e equals a 1. Because these bases are the same, and they cancel out to be just 1. So for that matter, the log of 10, what do you think that is? Well, the base is 10. Those bases are the same. Still becomes 1. Another accepted fact is the log of 1 is equal to 0. And another accepted fact is log of 0 is undefined, as in has no value you can operate with. It doesn't exist in our universe. All right, moving on. All right, just a quick check on what you just picked up. We now know that this is a base and that's a base. So the question is, what is the value of each of these expressions? You can plug this in the calculator. However, if you plug the log into the calculator, if you just hit log in the calculator says log of what? And it's waiting on you to plug in something there for log. And if you notice this base here, well, you plug in 5 there, just for the record. But this base would be 10, and the base you want is 5. So there's no way you could plug in the base of 10. So because of that, we need other ways of finding out what the value of that is. First of all, log base 5 over 5, you got to recognize those bases being the same, so it's 1. Anyway, since I'm talking about it, I may as well tell you this rule. The reason why this is equal to 1 because of the change of base rule, which is the last rule of property with logs. Basically, what it means is, if I gave you log base b of y, and again, this base is something other than 10 or e, I can rewrite this as log of y divided by log of b. So it's log y divided by log b. Notice, what's the base on each of these? It's 10. So your calculator can actually find the value of it for you. If you simply plug in log of whatever the first number is, divided by log of the bottom number. So the reason why this is 1 is because technically it's log of 5 divided by log of 5. Well, what is any number divided by itself? Well, it's 1. That's the reason why when those bases are the same, it gives you just plain old 1. All right, so to give you another example, change the base rules before I go on to number 2. Okay, so considering what we already know about the change of base rule, is it actually really easy to plug into your calculator? Even though your calculator doesn't have a log of base 3, we know that we can rewrite this as log of 9 divided by log of 3. And if you take a moment, plug into your calculator right now, pause the video, plug into your calculator, and then tell me what you come up with. So I'm going to wait for you to pause it. So you find a value, right? I'm going to bet you got 2. Kind of knew it was 2 without plugging into the calculator, even though that's a wonderful rule to follow. Take a look at this. This is 9, right? This is really log base 3 of 3 squared, right? So if that's the case, because 9 is 3 squared, so I can call that log base 3 of 3 squared. If that's the case, I can rewrite this as 2 times log, well, the 2 can come down, right? So 2 times log base 3 of 3. Well, what is log base 3 of 3? Well, we just decided that was 1. So it's 2 times 1, giving you 2. So I know I can answer that without a calculator if I recognize that these can be written as numbers as the same base. So I can rewrite the 9 and the 3 having the same base. 25 and 4, not so much. So I pretty much need a calculator in this case. So this will wind up being log of 25 divided by log of 4. So you can plug in the calculator and figure out the value of that. I'll tell you now. And I'm getting 2.3219, roughly, about 2.3219. All right, so enough of that. Let's go to the next 2. And this is actually really easy. You should recognize, well, 4 natural log of e. You may already know what it is. The base there is e, so this becomes 4 times 1, which is 4. And this next one you may recognize, well, we talk about subtraction. What does subtraction mean to do with logarithm, with the number that follow logarithm? Well, it means to divide those numbers that follow logarithm. So it's log x squared over x, which is log of x. All right, enough of that. One last type, and then we're done talking. All right, so in this one it says solve the log equation, solve the equation for x. And I love this question because for one, it deals with our properties on this side. So our one property says that addition means multiplication. So I can rewrite this as log base 6 of x times x subtract 9. And that's equal to 2. Which is really cool because now I have a new property. I got another property that says I can take this 6 and raise it to that power, right? So I have 6 squared equals to x times x subtract 9. Which gives you 36 equals to x squared subtract 9x. Which is a quadratic equation. You subtract 36 on both sides. And you get 0 equals to x squared subtract 9x subtract 36. You know, we've been solving this for quite some time now, so you should be pretty decent at this. I'm going to let you have it from there. Solve this equation for x, and then go back and decide if they actually work. For example, if you actually get negative numbers here. If you get logs of negatives. I got to stop. That's all I have. Good luck.